This is Juno 7, question 3. A small sphere rolls off the edge of a horizontal table with an initial velocity v0. It falls to the floor in a curved path as shown in figure 3.1. The velocity of the sphere at the point A is represented by the vector v. This vector makes an angle theta with the horizontal. By careful drawing on figure 3.1, show the construction used to resolve the velocity v into its horizontal and vertical components. Label the components Vx and Vy respectively. So because this is falling, I'm actually going to draw this in. I'll just maybe scan in a wee bit for you there. I'm going to draw the two components like this. Okay, and since this is the one beside the angle, then this one is going to be V, and it's going to be, because it's beside it, cos, and then this is the opposite one, V sine theta. And in terms of V and theta, write down the expression. So this equal to I would say Vx and Vy. So I have the expressions written in there. The Vx one is V cos theta, and the Vy one is V sine theta. Part 3. Air resistance to the motion of the sphere can be neglected. On the axes on figure 3.2, sketch graphs to show how Vx and Vy vary with time t from the instant the sphere leaves the table. So Vx there is a horizontal one. It doesn't change, and so its velocity is going to remain constant. So we'll just draw a straight line across there. But Vy is a vertical one, and it of course increases due to acceleration due to gravity. And so if we just draw in here a line like that. In another experiment, a second identical sphere, S2, is dropped from rest from the edge of a table at exactly the same time as the first sphere rolls off the edge with velocity v0. S1 moves in a curved path shown in figure 3.1. S2 falls vertically. Air resistance can again be ignored. Which sphere of either reaches the floor first? So if we have a wee quick look at this, they're saying that there you've got one sphere going off the table like that, and a second sphere just dropping vertically like that. Now of course it's only the vertical component of this one which is affected by acceleration due to gravity, and therefore it's going to accelerate at exactly the same rate as this one, and so they should both reach the ground at the same time. So the answer is there that they both reach the ground at the same instant. Explain your answer, and so you can say that the vertical motions of S1 and S2 are subject to the same acceleration both start off with the same vertical velocity, or equal to 0, and therefore so both take the same distance to travel at the same time. Take the same time to travel the same distance. Or fall, actually fall, don't they?